Hello everyone, welcome to our chemistry channel ChemPhysics. In our previous video, we have discussed some MCQ type questions, how to balance chemical equation and assertion reason questions based on this chapter chemical reactions and equations. So link is available in the description box. Please go through it. So today what we'll discuss? Today we'll discuss some case-based study on this chapter. So here this one is the first question. What you can see here that we are taking the copper sulfate solution which is blue in color, and in this copper sulfate solution we are going to immerse one zinc rod. So what will happen? Now this is expected that the zinc and this copper sulfate they will react, they will undergo some reaction. And what is our observation? Here you can see that the color gradually fades away. Okay, the color of this copper sulfate gradually fades away, and this zinc strip now becomes some rusty appearance you can see here. Okay, and the color is brown. So the question is explain your observation. So this is our observation. Two observation is there. What are the observation? Number one, the color of copper sulfate solution fades away. This is our the first observation. And what is the second observation? That the zinc strip becomes brown colored. Now, in the second part of this question, that if the reverse reaction is possible, explain. So for this, to answer the second question, first you have to know that what reaction is actually taking place here. Here we are taking the copper sulfate aqueous and we are taking zinc. Now what will happen? It will undergo displacement reaction. This will undergo displacement reaction. Now what is displacement reaction? For this you have to know the metal reactivity series, and here is the metal reactivity series for you. As you can see, this is the series. Here the metals are arranged in such a order that if we move downwards, then what will happen? The reactivity of the metals will gradually decrease. So the first metal or the first element which is placed here, this is the potassium, then sodium, calcium, magnesium, aluminium, zinc and so on. And at the last part you can see this is mercury, then silver and this is gold. So as we move downwards, what will happen? The reactivity of the elements or the metals will gradually decreases. Okay, now in a displacement reaction, a more reactive metal. So the metals which are placed above hydrogen, the elements or metals which are placed above hydrogen, they are more reactive than hydrogen. So in a displacement reaction, a more reactive metal can displace a less reactive metal from its salt solution. So here in this question we have to that copper sulfate and zinc is there. So let us try to find out what is the position of copper and zinc in this reactivity series. So copper, here you can see copper which is placed below, and zinc. Okay, this is the zinc. So zinc is placed above copper. That means zinc is more reactive than copper. So zinc can displace this sulfate ion from this copper sulfate solution. Okay, so what should be the product? This must be ZnSO4 plus copper. Okay, this is a kind of displacement reaction. Now if the reverse reaction is possible, that means they are asking that is this possible that if we take zinc sulfate solution plus copper, then is it possible that copper will replace this sulfate from this zinc sulfate solution? Should we get this product copper sulfate plus zinc? So again look at this reactivity series. Where is the position of zinc? This is the position of zinc, and this is copper. So zinc is placed above copper. That means zinc is more reactive than copper. So a less reactive metal cannot displace a more reactive metal salt. Understand? So this reaction is not possible. So the reverse reaction will not occur. And why not? Because zinc is more reactive than copper. So copper cannot displace this sulfate ion from this zinc sulfate solution. So move to the next question. Here again one diagram is there, as you can see. So what is this? The question is from the observation explain the reaction. So here rusting is happening. As you can see here rusting is happening. So what is rusting? You know that if we leave a piece of iron in open atmosphere, then the iron will react with atmospheric oxygen and the water vapor, and gradually it become rusted. So as you can see here. So from the observation explain the reaction. You have to write the reaction. What is the reaction? That 4 of iron plus 3 of oxygen. Now this iron will take up any amount of H2O, that means water vapor, from the atmosphere. Okay, X means any amount of water vapor it will take up. And what it will form? It will form 2 Fe2O3 dot X H2O. Okay, now what is this Fe2O3? This means the ferric oxide. This means the ferric oxide, and which is brown in color, as you can see here. Okay, the iron object, now some browny appearance is over the surface of this iron material. Okay, so this brown color is due to the formation of ferric oxide. And don't you think that some amount of water molecule is also there in the structure of Fe2O3? Yes, some amount of water molecule is there. So this is the hydrated oxide. Okay, this is the hydrated oxide. Why hydrated? Because hydrated means with water. Okay, so this one is the hydrated oxide of iron. So the next question, what are the necessary conditions for the reaction? So what are the conditions? So the most important is that number 1, the most important is that there must be present oxygen. There must be present oxygen. Understand? And what is the second point? Water vapor must be available in the atmosphere. Water vapor must be available. Okay, so these two are the necessary condition for rusting. If you think that rusting will happen if there is no water molecule, this is not possible, because in the formula of the rust, this is nothing but rust. There are H2O molecules. So from where the rust can get this H2O? Obviously from atmosphere. Okay, so for rusting, these two conditions is solely important. The first one, there must be present some oxygen, and second, water vapor must be available in the atmosphere. Okay, so move to the next question. Okay, so this is the question number 3. What you can see here, as because these are case-based study, they may give, okay, the board may give some kind of pictures or diagrams, flow chart. So first you have to interfere something. Okay, you have to infer something from these diagrams. So in this diagram, as you can see that here we are taking one test tube, and in the test tube some blue colored crystals are there. Okay, and then we are heating it through a burner. So what is the question? A blue colored crystal is being heated. The color will change to white. Again, if you add some drops of water to the crystal, color will regenerate. So what the crystal may be? This is the first question. So the blue colored crystal, you know what is the blue colored crystal here? This is nothing but copper sulfate along with this 5 water molecule. What this 5 water molecule in copper sulfate called? This is called the water of crystallization. This is known as the water of crystallization. Now if you heat it, okay, now if you heat it, then what will happen? As because the bonding between this copper sulfate and this 5H2O molecules is weak, and which is here assigned with a dot sign. Okay, the bond between copper sulfate and this 5H2O molecule, this is weak in nature. So if we heat it, what will happen? This weak bond will break. So we will get copper sulfate along with 5H2O molecules. Okay, now keep in mind one thing, that the blue color of this copper sulfate crystal is due to this presence of water of crystallization. Okay, the blue color of copper sulfate crystal is due to the presence of this water of crystallization. So this is blue colored. But if you heat it, what will happen? It will lose all the water of crystallization molecules. So this is the anhydrous copper sulfate. Okay, this is the anhydrous copper sulfate, and which is white in color. Okay, and so what the crystal may be? So we have got that the crystal is copper sulfate. Now explain your observation. So we have explained the first term, that why the color will change from blue to white. Now again, if you add some molecules of H2O, then what will happen? Then copper sulfate, this anhydrous copper sulfate, then again will gain this 5 molecules of water of crystallization. So this is the hydrated form of copper sulfate. Okay, this is the hydrated copper sulfate solution. And again, what will happen? The blue color will again appear. Understand? So this question we have done. So again, move to the next question. So this is the next question. That a substance A is used in painting industry. Mixing of A with water is exothermic and gives B. B is applied on walls. After a few days, the walls gets a shining appearance. So what is A and B? So here, what should be A? Okay, first you know that what is exothermic. Exo means out. Okay, exothermic. Now this exo means out. That means energy will be released in this reaction. Okay, energy will be released in this reaction. Okay, very good. Now this substance is used in the painting industry. So this is CaO, which is nothing but the quicklime. Okay, quicklime is used in painting industry. Now if it reacts with water, what we will get? We will get calcium hydroxide, CaOH whole 2, plus a huge amount of heat energy will be produced. Okay, that is why this is an exothermic reaction, and this one is the calcium hydroxide. Okay, so mixing of A with water is exothermic and gives B type of product. So A here is the quicklime and B here is the calcium hydroxide. Now B is applied on walls. After a few days the walls get a shining appearance. Why this is so? What is B? B is nothing but calcium hydroxide, CaOH whole 2. Okay, it will react with atmospheric carbon dioxide. Then it will form the calcium carbonate, CaCO3, along with some water molecules. Now this calcium carbonate, this is white in color. Okay, and it has a shining appearance. Okay, that is why if we apply this calcium hydroxide in the walls, then it will react with the atmospheric carbon dioxide. It will form calcium carbonate, which is white in color, and that is why a shining appearance you can observe. Okay, so this question also we have covered. Okay, so what is A and B? A is the quicklime, CaO, calcium oxide, and B is CaOH whole 2, calcium hydroxide, and this is the reaction. Write down the reaction. So this is the reaction, that why the walls gets a shining appearance. So thank you for watching our video, and if you think that this is useful, then please like, share and subscribe.